Okay. Now 303 equals to, what is A? 102 plus n minus 1 into d. What is the common difference? It is 3, right? So this becomes 201 by 3 equals to n minus. So we are starting with this topic, which is basically the fundamentals of mathematics. Now, when you come to 11th class, it feels like there's a lot of things, right? So first thing you should focus on is the fundamentals, right? And they are mostly whatever you have studied till 10th class. So let's get started. So fundamentals. Now, first topic which we'll study here is how to calculate or find the number of terms, right? It has various applications, a few of which are generally, in your asked in your questions in your syllabus. I have written over here. So let's say you are given this question that there's a series. Now this is obviously not a series. This is actually a sequence. So you might be confused what is the difference between the two. So for the moment, you can just assume that this is a sequence. Now somebody asks you to find the number of terms in this sequence. So this looks like an AP, which is an arithmetic progression, right? So what we can do is, since we have the last term here, so we can find what term is it of this entire AP, right? So 303 is a plus n minus 1 into d, right? Because an is equal to a plus n minus 1 into d, where n is the term, right? And obviously it has to be a, you could say, a natural number, right? Okay. Now 303 equals to, what is a? 102 plus n minus 1 into d. What is the common difference? It is 3, right? So this becomes 201 by 3 equals to n minus 1, right? Now obviously 201 is divisible by 3 because the sum of all the digits is a multiple of 3, right? So we can just use, very basic, right? There are a lot of ways to divide, right? Obviously, but very basic, right? What? 6 times, so 18, and then 21, so 7, right? So 67 plus 1 is your n, right? So therefore there are 68 terms. Okay. Now another application is when somebody asks you that, okay, let's say this is a sequence. How many perfect squares or perfect cubes are there, right? So let's talk about that. Now you have 1, 2, 3, so on till 200. So 1 is a perfect square, right? 4 is a perfect square, right? Perfect square simply means the square of the integer, right? Basically 3 is not a perfect square, because what number has its square as 3, right? Is it some natural number, integer? No, it's a irrational number, or it can also be minus root 3, right? Okay, so therefore this is not a perfect square. Now I know a lot of confusions are there in the minds of people who just enter 11th, that about squares and all. They think that whether root 4 is 2 or whether it is minus 2. So all of this will be cleared, but just so you know that it is 2, right? Root is always a positive number. Okay, so it is 1, 4, 9, and then somebody can even see that, okay, the last perfect square that you'll have is 196, which is actually 14 square, right? So yeah, so what you can do is, to solve this, see, you're starting with 1 and going till 200, right? So you're covering every number from 1. So you just take the square root of 200, because you're talking about perfect square, so you will take the square root. If we were talking about perfect cube, you would have taken the cube root, right? And you have to find this basically, right? So you can say this would be something 14 point something, right? 14 point something. Now you have to give the answer as only this part. Basically you can say only the whole part and not the decimal part, right? So either somebody could do it using this, or if somebody just knows that, yeah, this is how the perfect squares are there, right? Okay. Now, if you see this question, I have changed one thing here. Instead of starting from 1, it is starting from 101. So it doesn't matter. What you can do is take the square root from 1 to 200, right? So this thing, and subtract from 1 to 100, right? So 100, right? Now this is 14 point something. Now this is what? This you know, right? This is 10 exactly. So answer is what? 4 point something. And as I said, you have to take the whole part only. So your answer is 4. So there are 4 perfect squares between, or you can say in this sequence, right? What are these 4 perfect square? You can even write it, right? You know, one would be what? 121. Another would be what? 144. Another would be what? 169. Another would be what? 196. And that's it. This is the square of 11. This is 12 square. This is 13 square. And this is 14 square. Perfect. Now, one thing I must recommend you is that please, you don't need to, like memorize it. If you see it once or twice, it will be remembered by you, right? Please remember all the, squares from 1 to 50, I would say, and cubes from 1 to, you can say 30 maybe, right? Actually, what happens is, right, JEE, so you're like entering in 11th, right? JEE is very creative about their questions, right? Right now, we are in 2026. Last year was 2025. A very amazing thing about 2025 is that it is square of 45. So, they used this fact in a few questions in JEE mains, right? Even IIT can use this in their JEE advanced paper, right? So that's the thing, right? So if somebody asks you, so you can say that, okay, 2026 is obviously greater than 45 square, and it will obviously be less than 46 square, right? So just as a fact, you can, remember this. So that is why I'm saying that up till 50, you should know. Okay. Now, our third use case is found in divisibility. So let's say somebody writes this sequence 1, 2, so on till 250. And I ask you, how many numbers are divisible by 3, right? So simply what you'll do, just divide. Since it's starting from 1 only, you can just divide it by 3 and give the, again, the whole part as the answer, right? So let's divide it. So 8, right? So 24 and then 10. So that means 3, right? So 83 point something. So my answer is 83, that there are 83 numbers.
Exams, this turns into confusion and blank moments. With one-to-one mentoring, every mistake is corrected and real improvement begins.